What if you don't have a pi? What if there's no pi in there? Again, keep in mind that anytime you have pi, it's equal to 180 degrees. Well, if pi is equal to 180 degrees, what is pi divided by 180 equal to? 1. What's 180 divided by pi equal to? 1. These are your conversion factors. I don't know if any of you have had chemistry. You deal a lot with conversion factors when you're doing chemistry. We're doing the exact same thing here. If you want to change in this problem 12.3 radians, and I'm going to write that as not just 12.3, but 12.3 radians, and I want to change that to degrees. Here's how I do it. We're going to multiply it times pi radians under 180 degrees. Now, here's how I know which one to put where. Your units should always cancel. If you're not taking chemistry, this will kind of give you a heads up, a head start on what you do in chemistry. If I have a radians on top and a radians on bottom, they're going to cancel each other out. So now I don't have any more radians left in my problem. I have only degrees. So what do? I take 12.3, multiply it times 180. On bottom, I take 1, multiply it by 3.14159. Not 180 degrees. If you multiply 1 times 180, you're going to end up with the exact same thing. But on top, 12.3 times 180. On bottom, 1 times pi, and then divide the two. So that ends up with, let me pull up my calculator. Clear. 12.3 times 180. Enter. Divided by, and you can use your pi button if you'd like, about 704 degrees. Any questions? And think about that, 12.3 radians. Go back to what we talked about the other day. We've got 0 degrees, 90 degrees, 180 degrees, 180 degrees, 270 degrees, and 360 degrees. And you could keep going, 450, 540, plus 90, 630, 720 degrees. You could keep going with that. Well, we've got 12.3 radians. The only thing that you know as of right now, pretty much, you got 0 radians, and pi and 180 is the same thing, but you're going to get used to more of these. So if this is 0, then this is pi is over here. Well, what would 90 degrees be? Pi divided by 2, which is about 1.57. That's pretty close, 3.14, because this right here is 3.14 radians. So this would be half of that. That'd be about 1.57 radians. I think this is about 4.71, something like that, radians. And then you got 2 pi, which is about 6.28 radians. So we're looking for 12.3 radians. So do you see that if this is 6.28, 12 point something would be nearly 2 rotations, which kind of checks out. 2 rotations would be 720 degrees. So 704 degrees would be slightly less than 2 rotations. Negative 23.6 degrees. Now we want to change this to radian measures. To change degrees to radians, you do the exact same thing. Negative 23.6. And you know what I'm going to do? Forget about the negative to begin with, just to clean it up some. And then we'll go back and just tack it onto the answer. So 23.6 degrees. Changing it to radian measures, here's what you do. You're going to multiply by your conversion factor. You're going to multiply times pi radians on top, 180 degrees on bottom. Again, the way that you remember how to multiply is make sure if degrees are on top here, that they're on bottom here, because we want our degrees to cancel out. We want to change degrees to radians. And again, I didn't mention this a while ago. I kind of skipped over it. You're multiplying by 1. That's perfectly legal. If you want to multiply something by 1, it's not going to change it. It might change its forms, but it won't actually change what it is. So we now have 23.6 times pi on top. We're going to take our answer and we're going to divide it by 180 degrees. So just type it in. 23.6 times pi. And then divide by 180. About 0.411. We'll call it 0.4119. Question. And then, yeah, since the whole thing was negative, let's put our negative back out front. So negative 23, that's a fairly small angle, right? Again, whoops. Think back to your XY axis. 90 degrees is about 1.57 radians. So therefore, because it's half of a pi. So 0.4 is not quite even that. It's about a third of that. Does that make sense? A third of 1.5 would be about 0.4. It would be less than a third. So therefore, a third of 90 is 30. So this is a little bit less than 30. So that sounds good. But just make sure, since that is a negative angle, if you were to graph it, that you would graph it in this direction. Moving along, 270 degrees. Here's my suggestion for these. I'm going to show you the hard way of doing it, and then we'll talk about an easier way. 270 degrees. The hard way of doing it is what we've been doing. Now, the shortcut I'm fixing to show you doesn't work on all of them. I know that 180 degrees is equal to pi radians. That's what I'm multiplying by. I'm multiplying by 1, but I'm also going to multiply by this to get my degrees to cancel. Since degrees cancel, I'm left with 270 times pi divided by 180. Don't actually multiply this out. If you can leave that pi as pi and leave it in an exact form, because these other ones, that answer was irrational. That wasn't an exact answer. When you're dealing with pi, if you can leave it as pi, it's great. What I would do is try to reduce. Cross cancel. 270 and 180. I know I can divide each of those by 10. That gets rid of the zeros. And I can divide each of them by 9, right? Turns this into a 3. Turns this into a 2. So I can leave that on top, 3 pi, over 2 radians. And let's go back and remind you that since pi is 180, 180 divided by 2 is 90. 3 times 90 does give you 270 degrees. But your shortcut. To work these, as long as you can remember, and you really don't have to memorize them because you can do the math real easy. Pi divided by 2 is 90 degrees. Pi divided by 3, some of the common ones, is 60 degrees. Pi divided by 6 is 30 degrees. And pi divided by 4, or pi over 4, is 45 degrees. If you remember those, you can do these problems pretty easy. Take these common ones that I just wrote down. Isn't there a relationship between 90 and 270? How many 90s are in 270? So therefore, since there's 3 90s in 270, would 270 not just be 3 of these? Answer, 3 pi over 2. That makes sense. Much easier. And these are your common, that 30, 60, 90, 45, these are your common first quadrant angles. Let's do a couple more shortcut ones. Let's do 120 degrees. What's the relationship between 120 and, there's actually a relationship between 120 and 2 of those. You can either use pi over 3 or you can use pi over 6. How many pi over 3s is this? 2 of them. Because if pi over 3 is 60, well, it's 2 60s, not 120. So we can simply write that as 2 pi over 3. Well, why can we use 2 different ones? How many 30s are in 120? 4 of them, right? So you could also write that as 4 pi over 6. Is that the same thing? Yeah, it's just not reducing. What about 210 degrees? I'll give you a second to think about this one. 210 degrees. Try to find a relationship between one of those common angles that I put up there and 210 degrees. Which one is it related to? Good. How many 30s is it?
7.
So 7 pi over 6s. That makes sense. Good. Here's a hard one. 225 degrees. There's only one it can be related to. Yeah, 45. There's no way that you're going to multiply 30, 60, or 90 by anything that ends in 5. So anytime you have one of your common angles and you need to change it to a pi over a radian measure, 225, how many 45s is that? Anybody know? That is 545. So that'd be 5 pi over 4s. Any questions? Here you go. Now let's put two lessons together. Coterminal radians. Reminder from the other day, two angles are coterminal if they share the same terminal side, such as 30 and 390. They end up in the same spot. We find coterminal angles by adding a rotation or taking off rotations. So we find coterminal angles by adding 360s or taking away 360s. That's the way I did it with 30 degrees and 390 degrees. But the problem is, what if you have something like pi over 6? Well, I just worked it. Right? To take pi over 6 and you add a rotation or you take away, well, one way of doing it, if you want to change them to degree measures and then add your rotations, take them away, that's fine. Another way, though, it says find two positive and two negative angles that are coterminal with this. Instead of adding, when you're dealing with radian measures, instead of adding 360 and taking away 360 degrees, you add 2 pi and you take away 2 pi. Because again, 2 pi is 180, 2 pi is 360 degrees. So all you've got to do to find coterminal here, take your pi over 6 and add 2 pi. We need common denominators. We multiply top and bottom by 6. So that'd be pi over 6 plus 12 pi over 6. We good? Which is equal to 13 pi over 6. There's one of them. If you wanted to add another rotation on, you've already got your common denominator here. So add another rotation onto that. So another 12 pi over 6 would give you 25 pi over 6. So there's two positives. Now let's go the other direction. Let's take away. So you've got your pi over 6, and let's take a rotation away from that, which is minus 12 pi over 6, which would be negative 11 pi over 6. Or take away another rotation, and you get negative 23 pi over 6. And you can always check yourself. You can change these back to degree measures. We know that pi over 6 is 30 degrees. And we could go back here and take this and change it back to degrees. This is 13 30s. You see that pi over 6 is 30 degrees. 13 30s would be, does anybody know that right off the top of your head? 390. Good. 25 30s. That'll be 750. And you can take that 30 degrees, add 360, add 360 again, you do end up with those exact same numbers. The only other issue is if they wanted their answer in radians and you changed it here to get your coterminal, then you'd have to change it back into radians. So it's better to just know that you add or subtract 2 pi from it. Now sine, cosine, and tangent radian angles. This is not going to be an issue. This is just showing you that on your calculator you can type in radian measures as well. If you're working a problem and you have to find the sine of 0.54, make sure you're in a radian mode. Okay, there's no degree sign there, so therefore you know that you're radians. But you can think about it though, sine of 0.54, that's going to be, let's see, I told you that, let's see, 1.57 was pi over 2 or 90 degrees. So therefore 0.54 would be about a third of that. This is about sine of 30, which should be somewhere around 0.5 itself. So we make sure we go to mode. We make sure we come down here and change back to radians. We quit out of that and we just type in sine 0.54. Should get somewhere around a half, yeah, 0.51. Cosine 3.1, I'm not going to go through all these. Cosine 3.1, tangent 5.2 do the same thing. The cosine of pi over 8 you can type in just like it is. Cosine of pi divided by 8. And you get, and pi divided by 8, let's see, pi over 4, that's 45. So that'd be the cosine of 22.5, right at it, which is about 0.92. And tangent of 3 pi over 8 would do the same one. Okay, I'm not going to go through all those. That's kind of self-explanatory. Some common sine, cosines, and tangents. The same way that we went through, and I showed you with the sine 30, sine 45, sine 60, sine 90. We took those 30, 60, 90s, and we used our 30, 60, 90, 45, 45, 90 right triangles to find the sine of 30, find the cosine 45. This is the same thing. These are some of your common angles. Now, I'm going to be completely honest with you. When I say the cosine of pi over 6, I don't know what the cosine of pi over 6 is. It just doesn't flash in my head. What I do first, and probably the same thing you're going to do, is I take that pi over 6, and I say, oh, that's 180 divided by 6. That's the cosine of 30 degrees. That way you don't have two different sets of angles to memorize here. So sine of 0, 0 radians, 0 degrees, same thing. You can look back at your chart that you have that you're going to memorize. The sine of 0 degrees is 0. The cosine of pi over 6, which is the same thing as the cosine of 30, should give you root 3 over 2. The tangent of pi over 4. Somebody help me. What's pi over 4? 45. Tangent of pi over 4 is 1. Tangent of 45 is 1. The cosine of pi over 3, that's the cosine of 60, is a half from your chart. And the tangent of pi over 2 is the tangent of 90, which is undefined. Let me show you a trick. The common ones that you're memorizing, and this might help some. If you can picture this, if you can do a mental picture while you're working these out, much easier. Let's go through the sine, and we're just doing first quadrant to begin with. All this is first quadrant. 0, 30, 45, 60, 90. That's the ones that we're learning so far. If I ask you what the sine of these angles are, 0, 30, 45, 60, 90, try to relate this. Sine is very closely related to a y value. And I hate that I meant to go over this the first time we went through it. Sine is very closely related to a y value. And imagine that you had, let's do this. Let's go out a radius of 1 from our origin, and you put a dot on each of these that's at a radius of 1. You see that circle that you got formed. Your sine values are the exact values that your y values would have here on this circle. What I mean by that is, if you could find the y value here, that'd be the sine of 0. If you could find the y value here, that's a sine of 30. The y value here is a sine of 45. So you see your y values. Well, first off, what's your y value here? 0. Sine of 0 is always 0. Sine is related to y's. Cosine, here in a second, cosine will be related to x's. So if you have this radius of 1, just keep in mind that I go out 1 here. You see my sine's a little bit higher there. My y value is a little bit higher. You go 0. Your y value here is 1/2. Root 2 over 2. A little bit higher. Root 3 over 2. And radius of 1, right? What's my y value here? 1. The sine of 90 is 1. So the sine of 0 is 0. Sine of 30 is 1/2. Sine of 45, root 2 over 2. Sine of 60, root 3 over 2. Sine of 90 is 1. Any questions about those? Or we do cosine. Cosine is related to your x values. Radius of 1. What's my x value here? That's the 0.10, right? So my x value here is 1. And do you see that it's just going backwards? My x value here, it gets a little bit more, get a little bit closer to the y-axis. My x value here is root 3 over 2. My x value here is root 2 over 2. My x value here is 1/2. My x value here is 0. Good deal.